Hello everyone. In today's class, we'll be discussing about carrier sense multiple axis with collision avoidance. In the last class, we had seen in the wired networks, carrier sense multiple axis with a collision detection is proposed. Here the basic idea is that a station needs to be able to receive while transmitting to detect collision. And when there is no collision, station receives only one signal, that is its own signal, and when there is collision, station receives two signals, that is own signal plus the signal transferred by the second station, that is the jamming signal. So in the case of the collision, the detected signal will be double. It will have a double energy. So the collision can be detected. But let us move on to the wireless network. To avoid collisions on the wireless network is a must because here the collision cannot be detected. The received signal in the wireless has very little energy and the collision adds only 50% of the energy and it is not useful for the effective collision detection. Thus, it is the main reason in wireless networks the collision should be avoided because they cannot be detected, which is very important. To avoid collisions, carrier sense multiple axis with collision avoidance was invented. Here, the collisions are avoided by using three strategies: interframe space, contention window, and acknowledgement. This is the flow diagram of CSMA-CA. To know what is interframe space, which you can see in the flow diagram, what is RTS, what is CTS, what is contention window, what is acknowledgement, let us look into each and everything in detail. So this is the timing diagram where you can see once again the contention window, IFS, that is interframe space, and then sending a frame timeout. We'll come back to these both after few slides. First, let us see interframe space. When the channel is idle, station does not send the data immediately. That is the main concept used. So, the collisions are avoided. It waits for a period of time called interframe space, or in short it is said as IFS. Even though the channel may appear idle, when it is sensed, the distant station may have already started transmitting. And that signal has not yet reached this current station, because of which there will be collision. So in order to avoid that, the interframe space, that is a period of time during which even though the channel is idle, the station waits. If after the interframe space, the channel is still idle, the station can send, but it still needs to wait a time equal to the contention time. And by using an interframe space, we can prioritize the stations. That is, station that is assigned a shorter interframe space has a higher priority. We can see here, initially the channel is sensed. Here carrier sensing is used. If it is busy, it is continuously sensed till it finds as idle. It is one of the persistent method. Once it finds as idle, it waits for an interframe space. So, after this interframe space, still if the channel is found idle, then it has to wait for still more time, which is said to be contention time. So contention window is the amount of time. It is divided into slots. A station that is ready to send chooses a random number of slots as its wait time. And the number of slots changes according to the binary exponential backoff strategy. That is, it is set to one slot for the first time and then the value of it doubles each time. The station cannot detect an idle channel. That is, if the channel is not idle, that means channel is busy, then in that case the number of slots will be doubled, and that is said to be the contention window. One interesting point is that in the contention window, the station needs to sense the channel after each time slot. If it finds the channel busy, it does not restart the process. It just halts. And only when the channel is idle, it restarts the process. That means whenever it is idle, it restarts the process, and whenever it finds it as busy, it will be in the contention window. So we can see here the same thing. In the contention window time, it is the number of slots which will be depending on the binary exponential backoff strategy. That is, the value of R will be 0 to 2 power k minus 1, as we have seen in the pure Aloha CSMA CD. It is to calculate the backoff time, that is the value of R which is taken. And once it finds it as busy, then it starts to send the frame. Once it finds it idle, it starts to send the frame after the contention window. And here there is a provision of the acknowledgement. The positive acknowledgement helps to guarantee that receiver has received the frame. In the case of a CSMA CD, the lack of collision itself is an indication that the data has arrived. But here the acknowledgement is needed because the station does not have any means to check for the successful arrival of the data at the destination. Now let us see about what is CTS, what is RTS. After it is explained, we'll be moving back to the flow diagram of CSMA-CA. So first is about CSMA-CA and network allocation vector. It is said to be the frame exchange timeline. Before a frame is sent, the source station senses the medium by checking the energy level. The channel uses persistence strategy until the channel is idle. Once the station finds the channel to be idle, it waits for DCF interframe space. It is DIFS, and then the station sends a control frame called request to send, that is RTS. After receiving the request to send and waiting for a period of time called short interframe space, that is SIFS, the destination station sends a control frame called clear to send to the source station. This control frame indicates that the destination is ready to receive the data. So once the destination sends the clear to send, it will be ready to receive the data. The source station sends data after waiting for a time equal to SIFS, and the destination after waiting for a time equal to SIFS sends the acknowledgement. And there is something called as network allocation vector, which you can see here. Here in this case, we can consider that A is the source and B is the destination. First, after waiting for a time DIFS, request to send is sent from A to B, and the destination device sends clear to send in return, which is an indication that it is a control frame which indicates that destination B is ready to receive the data. After a time interval of SIFS, it is an interframe space, short interframe space, the data will be sent over the channel. And After a short time duration, acknowledgement will be sent back. This is how the data will be sent. In addition to that, you can see that the destination sends a clear to send, which will be sent or broadcasted to all the other stations involved in the network. And this clear to send message will have the duration during which the medium will be occupied for the transmission between A and B. So what is done? During this duration of the time, all the other stations will be refrained from sending the data, and they will be in the network allocation vector state. And there will be a counter setup or the timer setup, and once it finishes the transmission, acknowledgement will be sent, which will be received, and then all the other stations will contend to access the medium. So here network allocation vector shows how much time must pass before those stations are allowed to check the channel for the idleness. Here, in addition to that, if there is no CTS, that means it gives an indication that there is a collision during the handshaking process. And here there is a hidden station problem which can be avoided by using these RTS and CTS. That means because of CTS, it gives an indication to all the nearby stations to get to know that there is one hidden station which is already using the medium, so that the other stations are refrained from sending. So the hidden station problem will be overcome. So we can see finally here the flow diagram of CSMA-CA. So whenever a station has a frame to send, first initially K is equal to 0 is set, which is the number of attempts. Then the channel will be sensed. It is said to be carrier sense. Channel will be sensed to find out if it is idle or if it is busy. In the case if the channel is busy, it will be continuously sensed. If the channel, once the channel is found as idle, it waits for an interframe space duration of time. After that interframe space, it enters to the contention window state, and here it chooses a random number of slots R between 0 and 2 power k minus 1 and uses that rth slot. And once it finds the channel as idle, if it is busy, it will be in the halt state. Once it finds it as idle, the process continues. It is sending the data. It sends a request to send frame. It sets up a timer. When it receives the CTS, that is clear to send, before the timeout, then it waits for an interframe space time, which is a short interframe space time. Then it sends the frame or the data. Once again a timer is sent for the timeout. Within that timeout, if the acknowledgement is received, then it is success. If not, the K is incremented and back-off strategy is used, as it was used in the pure Aloha and CSMA-CD for the next attempts. So next, once again, it sensed. If it is idle, it waits for interframe space. Once again, it continues to remain in the contention window state. Still, if it continues to be idle, it sends the data. And when it sends the data, which you can see here, interframe space, contention window, then it sends the data. And within the timeout, if the data is sent, acknowledgement will be received within the timeout. And which you can see here, in addition to that, when it is sending the data, that part we have to see. First DIFS is sent, which is a time duration during which the source will be waiting to send the data. It sends request to send. Then it waits for the reply from the destination. After some time, SIFS, short interframe space, it sends CTS, then clear to send. A sends the data. When it sends the clear to send, it sends to all the nearby stations, and a network allocation vector will be set up which refrains other stations from sending the data over the same medium. So the hidden station problem will be solved, and then once the data finish sending the data, acknowledgement will be sent back, and thus it gives an indication that the other stations can access the medium, and the similar process continues. So in the case of a CSMA CA, we can see here that by using interframe space, contention window and acknowledgement, collisions are avoided. Thus, collisions are avoided here by setting up a network allocation vector, which is a timer, and also by having interframe space and the contention window. So collisions will be avoided, which you can see it in the flow diagram. So just